Hey, welcome back, Planet Numeracies. Mr. Noldy here to talk about how to complete a square. So first things first, naturally a square, say, is number-wise. 16 is a square because it can be written as 4 squared. So with that in mind, let's look at when or how we would complete the square. So what we're talking about is how to complete a perfect square trinomial. So for example, if I were to write down x squared plus 10x plus 25, that would be considered a perfect square trinomial because we could factor that. So factoring this looks like this. We're looking for factors of 25 that add to 10. So naturally 5 times 5 and 5 plus 5. So I would write down plus 5 and plus 5. So that's a perfect square trinomial because this piece here can be written as x plus 5 quantity squared. Okay, so this is about completing the square. So sometimes you will need to complete a square, say a squared trinomial. So let's go, let's say you have x squared plus, I don't know, 8x plus what number? Okay, what number right here would make this a perfect square trinomial? So you're asking for the number that when I write it out like this, will be a perfect square. Like the same number will go here as goes here. So the trick is you divide this linear coefficient 8, divide it by 2, and that's the number that's going to go here. 4 and 4. 8 divided by 2 is 4. But what number goes here? That's actually the number that completes the square. So what I would do is divide that by 2, got your 4, and then square the 4, which would make this 16. So this is equivalent to x squared plus 8x plus 16. This is a perfect square trinomial, and these are its factors. So the reason we call it completing the square is because I can now write this as x plus 4 quantity squared. Okay, so when might you want to be able to complete a square? So let's look at another page here for a moment. When might you want to do that? Well, suppose that you had a pre-calculus problem. Okay, we'll just make one up here. 4x plus 1. So this is used in pre-calculus, especially when you're dealing with a quadratic like this guy here. So it's an x squared. So what we want to do is make a trinomial that's a perfect square because we want to be able to write this in the standard form of a quadratic, which, quick review, looks like this. So it's y equals a times quantity x minus h squared plus k. And when we write a quadratic in this form here, we know what its vertex is. That's why this is sometimes called the vertex form, right? I know that hk is my vertex. I'll write vertex right here. So if we want to write this, if I type this into a graphing calculator, it's going to graph as a parabola, pointing up like this, okay? But to be able to tell where this vertex occurs, I need to be able to write it in this form here. So let's talk about what we just looked at. Switch colors again. There we go. So I could say that y equals x squared plus 4x. I'm just going to move this plus 1 over a little bit because it's still there. The plus 1 is still there. But what I'm going to do is take half of this and square it. So half of 4 is 2, and 2 squared is 4. So I'm going to write a 4 here. So that completes this part of the square. It becomes x plus 2. X plus 2 because the 2 is the half of this number here, the half of the linear coefficient. X squared plus 4x plus 4 is x plus 2 squared. But I still have this plus 1 out here. And can I just arbitrarily add 4 to any equation? No, I've got to offset it. So if I add 4 here, I can offset that by writing minus 4 because plus 4 and minus 4 adds up to 0. So we still have the original x squared plus 4x plus 1. So x squared plus 4x plus 1. But now we've completed this square, which is what this video is all about, and have written it in vertex form. So do my y equals. So the vertex form tells me that the vertex is -2, comma, -3. Because remember, I'll rewrite it, but the form of this that we were looking at, the standard form, also called vertex form, is HK is the vertex. So if you were to really write this in strict form, you would have x minus -2 quantity squared plus the -3. So that's where -2 is this -2 here, and the -3 is the y-coordinate of the vertex. So that makes graphing these much easier to graph. I don't have a graph right in front of me, but I can draw one up quick enough. If I were to graph this, this is just a quick sketch. -2, -3, so I go left 2, down 3. This would be the vertex. And from there, I would just graph the parent function, right? The parent function of y squared. So from this point right here that I just graphed the vertex, I'd go right 1, up 1. So let's put a point there. I go left 1, up 1, put a point there. Right 2, up 4, have a point there. Left 2 and up 4. So I've gotten a real quick idea of what this parabola would look like. And to do that, or by doing this problem right here, complete the square. So if you have any other questions, please leave a comment below. If there's any other skills you'd like to have a quick video made up, just let me know and I'll try to get one going for you. Thanks again, and talk to you next time.